Hello, we are from Varee, Chiangmai, Thailand. Today we're going to present our project, Deep Learning Live to screen COVID-19. The number of COVID-19 patients are rising, which make people have to get screening for COVID-19 disease. There are three main types of COVID-19 screening. Firstly is RT-PCR. Secondly is rapid test, and last is X-ray of the lungs. There are many problems from those tools, such as overpricing, long waiting period time for processing the result, and the distance problem from home to hospital.
We want to make a new digital technology that enables any user to rescale themselves and be more careful with their contract. We hope to develop faster and larger scale digital technology than other COVID-19 screening tools, and anyone can use with their smartphone for free.
COVID-19 and vocal cord study have shown that COVID-19 affects the upper respiratory in causing inflammation of the upper respiratory, causing a halt or decreased voice power. And from COVID-19 patients infected with COVID-19 in Thailand showed that they had pneumonia. Pneumonia cause affect the respiratory system. It makes breathing difficult. So we think that breathing affects the diagnosis of COVID-19.
Later, we try to find the different sound wave of COVID patients, but when we listening to the original data that have cough, voice, and breathing, we can't determine anything to define who is negative or positive case. Therefore, at first step, we have to try to extract more specific data as the effective feature. In this research, we extract data feature data for the following functions. First, MFCC, second, SGFT, spectral bandwidth, spectral roll-up, spectral set-point, roll square, and zero possibility, and use convolutional neural network to classify.
We deem that quality of our live bot well effective as ATK, and people can easily access our live bot.
For research procedure, first we will search for file preprocessing. After that, we will extract. Then model training and model deploy. After that, we will develop live bot, simulator, and experiment of actual use.
As for the data, we take the data from Project Coursera. The data set we bring are divided into three types. First is breathing, second is cough, finally is speaking.
For CNN architecture, first we feature stacking model. We design CNN architecture with stack of feature data of audio before feature model. And the second architecture is in as feature mapping technique. With the correlation of the dimension of the data, it was found that the data had different size and dimension. So we design this architecture that's in as feature mapping to extract another important feature and fit machine learning algorithm by support vector machine, multivariate logistic regression, gradual positive classify, and then neural network as well. For first model, we train hyperparameters with 5 model. After we train, we get the base model from shallow breathing sound that have base accuracy at 0.909 and base loss at 0.082. Confusion matrix from base model from model architecture 1, we got accuracy at 88.53%. For second model, we have to prepare data after train from edge feature before feed-to machine algorithm is clear. And after feed-to machine algorithm, we get the base model from shallow breathing sound tool that have average score at 0.958 from gradual positive classified. And confusion matrix from base model for model architecture 2, we got accuracy at 93.863%.
In a part of live bot development, more than 2 out of 3 of Thai population are use Line. That is why we use Line Official as the medium for the user and AI model. Firstly is Line bot. We will start by registering a Line Official account and then log in on bot Noi AI, then link the bot with Line Official to make a live bot. Secondly is Flag. We installed Flag software on a computer and then uploaded every model we use into it. Then choose the API feature on bot Noi. After that, we put the link from Flags into it. After that, we use the dialog feature to make a dialog. Then pull the Flags API to analyze if they had COVID-19 or not.
We develop live bot. We try to experiment of actual use for the field of our live bot. From 10 cases in positive, it's correct 7 cases, and from 10 cases in negative, it's correct 9 cases. Our model has accuracy at 87.5%, sensitivity at 70%, specificity at 90%.
In the implementation of the research, 7 characteristic extraction types were used to train the model. Some features have been found low relation may not affect to the prediction score, so next experiment will eliminating some of features. This should better result in processing time. We try to add more audio data set that will improve the accuracy of prediction. Finally, we found that the difference of type and model of mobile phone are important. So we will try the variety type of mobile phone to read and correct sample audio. This research found that voice of a COVID-19 patient can be extract feature data by using SCFT and MCC functions that get high accuracy to predict. The CNN feature mapping technique show result in higher classification accuracy as the model training state we have 98% accuracy and with LiveBot we have 87.5% accuracy. This result caused by noise while recording of voice. Thank you.